Good evening to one and all. Today we are going to discuss about concrete mix proportioning, an important topic in concrete technology. Before going to the discussion, myself, Dr. S. Davamanidas, Associate Professor, Department of Civil Engineering, Sedu Institute of Technology. So today we are going to discuss about concrete mix proportioning. It is a vital subject that should be known by a civil engineer for making good quality concrete at the site. So concrete is one of the versatile material which is widely used in the construction industry due to its numerous advantages comparing to other materials such as steel, wood, and etc. Some of the advantages of concrete are it can be easily made into any shape during its fresh state, and also concrete can be made at the site in a simple manner. The cost of the concrete is also comparatively lesser than other materials. So today we are going to discuss about some important points regarding concrete mix proportioning. Before that, we have to know about the course outcomes of the subject concrete mix proportioning. So after completion of the study in concrete mix proportioning, we should know the design of concrete mixes as per IS methods, the importance of mixed proportion in making good quality of concrete should be known, and also it should give us an idea about the influence of mixed design in fresh and hardened concrete, and also the role of importance of the material properties in the concrete mix proportioning. So today we are going to see two topics in mixed proportioning. One is principles of mixed proportioning, and the second one is the properties of concrete related to mixed design or mixed proportions. So first we will see about what is principles of mixed proportioning. General introduction about concrete is, I have already said that concrete is a versatile material for making infrastructures around the world. So basically the properties of the concrete is designed by the proportioning of raw materials used during the production of concrete. So basically to determine the relative amount of material involved in the process of making concrete is known as mixed design. Right? Once again I repeat it. The determination of the relative amount of materials involved in the process of making concrete is known as mixed design. In a proper way, if you want to define what is concrete mix proportioning, then we can say it like this: the process of selecting suitable ingredients of concrete and determining the relative quantities for producing concrete of certain minimum properties such as strength, durability and consistency, as well as economically also. So by the definition, what we understand is the mixed proportioning is a process of selecting the suitable materials or ingredients for making good concrete, and also we are going to define or determine the quantity of certain materials in order to make good concrete. For example, in our daily life, we used to cook food. That take it any recipe of a food, it should contain certain amount of vegetables, certain amount of rice or carbohydrate base, and certain amount of salt or sweet like that. If any one of the material is not sufficient or added higher amount, then the recipe will not be in proper way. So like that, whenever you make a concrete mix design, you have to consider all the properties of the materials and the factors which is going to influence the mix proportion. According to that, you have to select the materials and the amount of materials and the requirement of mix design. So following this, we can achieve a good mix proportion. Then next we can see the principles of mix proportioning. So the concrete developed using proper mix design should achieve some stipulated minimum strength and durability. The main thing for designing a mix of concrete is to achieve required strength and durability. And also the production of concrete should be as much as possible in economical way. Right? So the main thing is we have to produce a concrete with good quality. It should attain good strength, and also the durability of that concrete should be good. At the same time, the cost of the concrete should be in the line. If the production cost of the concrete is higher, then it is not in an economical way. So to produce a concrete in economical way is much required one. The economy means the cost of the concrete involves two factors such as material cost and the labor cost. So while we designing a mix or while we calculating an economy of concrete, we should consider two factors. One is material cost, which is the cost required for acquiring material, and the another one is for labor cost, which is to uh, spend money for making the work. So these are the principles of mix proportioning. And what are the objectives of mix designing? What is meant by objective? So the term objective refers that after why I am doing this design, that is called the objective. So why we are doing this mix design? The first one is to decide the proportions of the material which will produce a concrete of required properties. So first objective is what? We are designing the mix proportion to decide or to determine the proportions of material which will produce concrete of required properties. For example, if I require a concrete with an characteristic strength of M20, then accordingly I have to choose the proportion of binder material, filler material and water. So based on this proportion, we can achieve required properties. Why? Because concrete is a material which is made up of binder, filler and water. In the binder material, generally we used ordinary Portland cement, but we can also use other materials. The thing is, the binder material should possess some binding or should have binding properties when it is came into contact with the water, and these binder are responsible for achieving the strength of the concrete. So generally we use ordinary Portland cement in the traditional concrete, but in the recent days the use of ordinary Portland cement is replaced by blended cement by adding some pozzolanic material to enhance the properties of the concrete. Then the second objective is to achieve a concrete with desired workability in its fresh state and fluid enough to fill the formwork and surround the reinforcement fully. So first objective is to get a concrete with good strength and durabilities. And the second thing is during the fresh state the concrete should be workable and the flowability of the concrete should be in good terms. Then only the concrete will easily flow through the reinforcement drill and it will easily spread all over the reinforcement and it will make a good concrete. If the concrete is not in workable condition, then the mix will be made into dry mix and it is hard to make a structure, make a number with a desired shape. And the third objective is to achieve a concrete with desired strength and durability in its hardened state. So after 28 days of curing, the concrete should achieve desired strength and the durability should be good when tested for chemical resistance test and all. So these three are the predominant objectives of the mixed proportioning of concrete. So for our easy understanding through this diagram, we can easily understand what are the principles of mixed design. So there are four factors which will greatly influence the mixed proportioning design. One is placeability, the second one is durability, third one is economy, and fourth one is strength. So these four factors combine to make the mix proportioning, or they will decide what kind of mix proportioning is going to be happen. So the predominant one is first strength. If you doing a mix proportion for concrete, it should achieve required strength and the placeability should be good. Placeability is nothing but the workability of the concrete, and also it should have some durability. So after achieving all the three things, we should also focus on another factor called economy. So these four terms will frame the principles of mixed proportioning of concrete. Then the second point is the properties of concrete influencing design. So the mixed design is generally influenced by the properties of concrete. What are the properties of concrete? One is grade designation, the types of cement, maximum nominal size of aggregates, grading of combined aggregate, water cement ratio, workability, durability, and quality control. These properties of concrete plays a vital role in designing or deciding the mixed design of the concrete. So we can see in detail what are all these factors. Before that, this is a pictorial representation of materials used for making concrete. We use cement, sand, supplementary cementitious material which is used in the blended cement as a pozzolanic materials, and in water. In traditional innovative concrete, now we are going for chemicals to achieve required workability or required strength without reducing or increasing the amount of water, binder or filler materials. So first factor which is affecting the mix design is grade designation. So grade designation is nothing but it represents the strength of the concrete. It represents the strength of the concrete. So the concrete designed for a specific strength should achieve desired strength. So whenever we are designing a concrete, at the end of the 28 days, it should reach the expected strength. To achieve that, we have to follow the concrete mix design code 10262-2019, which is the latest version. So they framed a detailed procedure for achieving a required mix proportion for concrete with OPC cement, with blended cement, and etc. So based on the recommendations given in the IS code, to achieve the concrete mix, the first one, they are denoting a target strength. So the concrete should be designed for target strength. What is target strength? The target strength is higher than the required characteristic strength of the concrete. So based on the grade designation, the target strength value will be varying. And this target strength value is higher than required characteristic strength because at the site during the casting of concrete, due to poor workmanship or some other problems, the strength of the concrete can be reduced. In that case, to overcome that, if we designing a concrete for a higher strength than the characteristic strength, then these higher strength will taken care of the mistakes happened at the site. So whenever we are going to make a concrete design, the first step is we will calculate the target strength, which is higher than the characteristic strength. So for example, if we design a concrete mix for M20 grade, then the characteristic strength of the concrete at the 28 days should be what? 20 Newton per mm square, which is the FCK value of concrete for M20 grade of concrete. So to achieve this, we have to design the concrete for a target strength of 26.6 Newton per mm square. So similarly, for M30 grade of concrete, the characteristic strength of the concrete at the 28 day should be equal to 30 Newton per mm square, and the target strength should be around 38.8 Newton per mm square. Then the second property is the types of cement. So based on the cement, the strength of the concrete is going to be decided because cement is the binder material. So when cement is reacted with water, it forms a CSH gel. The CSH gel, calcium silicate hydrate gel, is purely responsible for achieving the strength of the concrete. So the types of cement, we have three grades of cement in olden days, such as 43 grade, 53 grade and 33 grade. So nowadays cement with the grades of 33 are not in the use. So here the grades of cement denotes the compressive strength of the cement mortar after 28 days. So if the grade of the cement is 43, then after 28 days the mortar strength of the concrete should be 43 Newton per mm square or above 43 Newton per mm square, but it should not higher than 53 Newton per mm square. If the cement grade is 53, then after 28 days the mortar cube strength should be around 53 Newton per mm square or higher than 53 Newton per mm square. So these are the two grades of cement we are using in the field. So whenever we require certain properties, we can use certain type of cements. For example, we are also having cement based on the characteristics, such as if you need a sulfate resistance, then you can go for a sulfate resistant cement. Or if you want to record a rapid hardening Portland cement, then you can achieve yearly strength concrete. Whenever the yearly strength of the concrete is required, then you can go for rapid hardening cement. Similarly, so based on the properties of the cement, our next design is going to be affected. So the fineness of the cement will increase the workability by reducing the friction between the aggregates. So based on the fineness also, the mixed design is going to affected. The third property is maximum nominal size of the aggregate. So the size of the aggregate plays an important role, and these size of the aggregates are measured or determined by using sieve analysis. So maximum nominal size of the aggregate used is governed by size of the section and the spacing of the reinforcement. The spacing of the reinforcement is a primary thing. Based on that, the size of the aggregate we can choose. If, for example, if the spacing of the reinforcement is lesser than 20 mm, then we should use an aggregate of size lesser than 20 mm, because if we use aggregate size of more than 20 mm, then there is no possibility of these aggregates to get into the reinforcement grill. So for that, the size of the aggregate should be lesser than 1/4 of the minimum thickness of the member, right? So the thickness of the member should be higher than the aggregate size, and the aggregate size should be lesser than the minimum thickness of the member. How many times? So 1/4 times. And also it should be less by 5 mm than the minimum cover to the reinforcement. So if, for example, if the cover of the reinforcement is 25 mm, then your aggregate should be 20 mm. If the cover of the concrete is 20 mm, then your aggregate should be around what, 15 mm or 12 mm, right? So to achieve high strength concrete, 10 mm to 20 mm are used. Then the next factor is grading of combined aggregate. So this is an important and interesting term. So what is meant by combined aggregates? The aggregates of different sizes are combined to improve the packing of the concrete matrix. So already we have discussed that concrete is a material of formed by combination of various materials. So here first the binder material, next the filler material and water, right? So the filler materials is formed of fine aggregate and coarse aggregate. Fine aggregate means, for example, river sand, and coarse aggregate means, for example, we can use crushed granite stones. The size of the crushed granite stone is higher. So the voids in the crushed granite stone is filled by the addition of sand. and after mixing this there will be some force. It will be arrested by the addition of cement. Similarly, if you using different kind of aggregates, then the packing of the concrete will be enhanced. If the packing of the concrete is enhanced, then automatically the compressive strength of the concrete will be increased, because the packing density plays a vital role in improving the concrete strength. The improvement in the packing of the concrete matrix will increase the strength of the concrete. Similarly, the aim of the combining the aggregate is to obtain aggregate matrix with proper gradation. So there is two types of gradation. One is poor graded and another one is well graded or proper graded aggregates. If we use proper graded or well graded aggregates, then it will have less force, and due to that the particle density of the matrix will be good, and it will have some higher compressive strength. So this diagram is a pictorial representation of the well graded, poorly graded and gap graded aggregates. So the usage of here in the first image we can see there is a lot of smaller particles and bigger particles. Here the voids between the bigger particles are filled by small particles, and the voids between these smaller particles will be covered by the cementitious materials, so that the pores in the concrete will be reduced. Because of that, it will have good bonding strength, and also the packing of the layer of packing is good, so that it will have good compressive strength. But here in the poorly graded concrete matrix, we can see there is a lot of spaces or voids between the aggregates. In the similar case, gap graded aggregates, one particular type of aggregate we are going to use, the size of the aggregate is similar, and due to that there will be more number of voids. So due to this, the poorly graded concrete and the gap graded concrete will result in inferior quality concrete. The next term is water cement ratio. So one of the important factor in the design of concrete is the water cement ratio. So based on the water cement ratio only, the strength of the concrete is determined. So the ratio of water to cement is a single most important parameter with regards of concrete quality. So theoretically, about 0.22 to 0.25 percentage of water is required for complete hydration. So here why we are adding the water means the cement have no bonding property unless it is reacted with water. When water is added to the cement, then there will be a hydration process. Due to the hydration process, the concrete is hardened, and then we achieve the strength. For hydrating the cement, we required only 0.2 to 0.25 percentage of water. Practically, the useful limit is around 0.33 percentage. 0.33, not percentage. Okay. So reducing the water for a given amount of cement will move the cement particles. Alright. So if we use higher water cement ratio, then the strength of the concrete is going to be reduced, right? At the same time, when we reduce the strength of the water cement ratio, then it will lead to increase in strength. At the same time, the workability of the concrete will be decreased. So reducing the water for a given amount of cement will move the cement particles closer together, which in turn densify the hydrated cement paste. If we increase the water for a given amount of cement, then the cement particle will not move closer to each other, and it will not make densified hydrated cement place, which will lead to inferior quality of cement paste. The next point is the increased strength and reduced permeability. So based on the water cement ratio, if the water cement ratio is balanced, it will increase strength and it will reduce the permeability. It also makes the concrete more difficult to work when the water cement ratio is reduced. So in the combination, the water cement ratio and the degree of hydration control many of the properties of hardened concrete. So the hydration of the concrete is mainly depends upon the amount of water we added, right? Similarly, the strength of the concrete is also decided by the amount of water we added during the mixing. So we have to use required water cement ratio for achieving good concrete. So for that, the strength of the cement used should be determined first, and when the cement strength data are available, based on that, in the IS 10262/2009, there is a chart with three similar curves for three different grades of cement. For 53 grade cement, for 43 grade cement, and for 30 grade cement, there is a chart. Based on that chart, we can decide the water cement ratio. So this is a pictorial representation how the water cement ratio is affecting the strength of the concrete. In the first diagram, you can see the cement content and the water amount is balanced, so that the concrete is feeling happy, right? Because the weight of the amount of water and the cement is balanced. The result is we will achieve a good concrete with good compressive strength. Similarly, if you see the second diagram, here the amount of water is increased, so that the amount of cement is lesser than amount of water, so that the concrete will lose its compressive strength, and here it is not advisable for making concrete for structural purpose. The other property is workability. The workability of the concrete is also mainly influenced by the water cement ratio. Here, the workability of the concrete for satisfactory placing and compaction is controlled by the size and shape. The size and the shape of the section, the quantity and spacing of reinforcement, and the methods employed for transportation, placing, and compaction of concrete. So here, what the 3 points are saying is, if we want to make a concrete with a rectangular section or a circular section or elliptical section, so based on the size, shape of the section, the workability is decided. If we are making a concrete for a simple rectangular section, then the workability may be lesser. So required amount of water for the hydration purpose and to achieve little workability, it is enough. If we are using a section with complex in nature, for that we have to produce a highly workable concrete. At the same time, it should also have required strength. For that purpose, we will not increase the water cement ratio, but at the same time we will add some admixtures or super plasticizers for achieving the required workability. The second one is the quantity and spacing of the reinforcement. So based on the spacing of the reinforcement, we will decide the workability of the concrete. If the spacing of the reinforcement is congested, for example, in the case of reinforcement for the slabs and all, the reinforcement spacing will be congested. So during that time or during a beam column junction, the reinforcement spacing will be congested. So to achieve a decent mix of concrete in that places, we have to increase the workability by adding some extra chemicals. And the third thing is the method of transportation, placing and compaction of concrete. If we are making a concrete at the site, then we can easily place the concrete within 10 minutes or 30 minutes, etc. If the uh, concrete is of type ready mix concrete, then it will be manufactured in the plant and it will be transported to the site. So if the time duration for the uh, patching plant and the site is higher or more than 30 minutes or 40 minutes, then the cement will start to set. So during that time, we have to ensure that for the 30 minutes or 1 hour, the setting of the cement is not completely done, so that we will add some extra admixtures. So based on the method of transportation, based on the spacing of reinforcement, and based on the section, the workability of the concrete is affected. Okay. So these are the factors which affects the workability of concrete. So generally the concrete mix proportion is mainly influenced by workability. So based on the required workability, we will design the mix. So in that, the workability is going to affect by a lot of factors such as water content, cement content, grading, aggregates nature, concrete temperature, humidity, compaction type, concrete placement, and concrete transportation. So these are the predominant factor which is affecting the workability of the concrete. If the temperature of a particular day is very high, then the concrete will be easily start to set easily. Or if the temperature of the particular day is very lesser, then the workability or the setting time of the concrete will be little bit increased. So due to that temperature, humidity, compaction type, the workability is definitely going to affect. And these are the some instruments used for testing the workability of the concrete at the laboratories. The first image shows the slump cone apparatus, which is widely used in all the labs, and also it is easy to used at the site also. So this is one of the most predominant instrument used for testing this slump. Then Kelly ball test, flow table test, compaction factor apparatus, and VB consistometer. All these three are will used only in the laboratory to decide the workability of the concrete. The next point which affects the mix design is the durability. The durability is defined as resistance to internal and external deteriorating influences. Whenever we made a concrete, the concrete should be free from foreign agencies. So, such as chlorine, sulfate, magnesium, etc. When the foreign body enters into the concrete through the pore, then it will affect the concrete. So to achieve that, we have to produce a concrete which has a resistance to internal or external deterioration influences, especially for the chemical attacks. So the requirement of the durability may be achieved by restricting the minimum cement content and minimum water to cement ratio. The last point is the quality control. So the method of controlling the differences in the strength of the concrete by reducing construction error. So basically what we will do means we will do good kind of concrete. We will in paper we will create a mix proportioning with the optimum ratios, but while in the site, when the engineer or when a mason is going to mix the concrete, we should properly maintain or we should properly supervise the mixing of concrete, unless there will be definitely some construction errors. So if there is higher construction errors, then our concrete strength will be reduced. For example, if the need of water is around 1 liter, at the site the mason will try to mix 1.5 liters or 1.25 liters of water to make it workable. When the concrete is workable, he can do the work easily. But as the engineer's point, if you add more water, then your concrete is going to suffer. So to ensure that the construction error should be reduced, for that proper quality control is needed. So in this lecture, we have seen two main points. One is principles of mixed proportioning, and the second one is properties of concrete related to mixed design. So these two themes are very important themes, and in the next class we will see how to make the mixed design of required strength. For example, M20 concrete, M30 concrete, M25 concrete. So we will see the mix procedures or how to make mix design of the concrete based on the recommendations of IS 10262 2019, which is meant for concrete mix proportioning. So till then, thank you for your patient listening, and I hope we will meet in another class. Thank you very much.